Our today's topic is theoretical distribution. So let's start with the introduction. With theoretical probability, you don't actually conduct an experiment, i.e. roll a die, or conduct a survey. Instead, you use your knowledge about a situation, some logical reasoning, and/or known formula to calculate the probability of an event happening. Definition: it can be written as the ratio of the number of favorable events divided by the number of possible events. Ratio equals number of favorable outcomes, number of possible outcomes. Let's take this example. If you have 2 raffle tickets and 100 tickets were sold, number of favorable outcomes 2, ratio equals number of favorable outcomes by number of possible outcomes, so 2 divided by 100 equals 0.02. Now, we study standard statistical distributions, example normal, Poisson, binomial, and their uses. So, start with normal distribution. It is often the case with medical data that the histogram of a continuous variable obtained from a single measurement on different subjects will have a characteristic L-shaped distribution known as a normal distribution. For example, one such example is the histogram of the birth weight, in kilograms, of the 3,226 newborn babies shown in Figure 1. As you can see in THS figure, in vertical we took frequency and in horizontal we took birth weight. Here, n equals 3,226, mean equals 3.39 kilograms, standard deviation equals 0.55 kilograms. Formula of normal distribution: y equals 1 divided by iota sigma into root 2 pi into e power minus x minus mu whole square divided by 2 into iota sigma square. Next is binomial distribution. Data which can take only a binary, 0 or 1, response, such as treatment failure or treatment success, follow the binomial distribution provided the underlying population response rate does not change. It is a discrete probability distribution. Binomial distribution is used when there are 2 exactly mutually exclusive outcomes of a trial. These outcomes are appropriately labeled success and failure. Formula of the binomial distribution. And this is the simplified formula of binomial distribution: px equals ncx p power x cube power n minus x. Let's take the example: a coin is tossed 3 times. Find the probability of getting 2 heads. So, there are total 8 cases in which head or tails comes, but chances of comes 2 heads is only possible in 3 cases, so p equals 3 by 8 equals 0.375. Next example is binomial distribution for n equals 20 with 0.25 in the normal approximate, so we took up to 20 in vertical, and in horizontal, that is normal response up to 10.3 as you can see in this figure. Next is the Poisson distribution. The Poisson distribution is used to describe discrete quantitative data such as counts in which the population size n is large, the probability of an individual event is small, but the expected number of events, n, is moderate, say 5 or more. Formula of Poisson distribution is px equals lambda t power x into e power minus lambda t divided by factorial x. Let's take example of this. In this example, there are 3 outages, so x equals 3 and e equals 2.718 is predefined, and mu equals 4. Put this into formula: mu power x into e power minus x divided by factorial x. Our today's
created using Powtoon.